Hello guys, I am Nikhil Shivraj from SVC Bangalore from Department of Electronics and Communication. Today our subject is network analysis. And our today's topic is Millman's theorem. So let's see what it is. Millman's theorem is a circuit with parallel voltage sources and internal resistance which can replace one equivalent voltage source connected in series with an equivalent resistance. This method allows us to determine the voltage across parallel branches of the network. When several sources are connected, this method reduces the complexity of the network. So here's the equation and the circuit diagram of Millman's theorem. If the n number of sources here, they have given n is equal to 3. So E equation will be given as E1 by R1 plus E2 by R2 minus E3 by R3 so on plus or minus En by Rn by 1 by R1 plus 1 by R2 plus 1 by R3 plus so on 1 by Rn, and R equation will be 1 by 1 by R1 plus 1 by R2 plus 1 by R3 plus so on 1 by R1 Rn. Steps for applying Millman's theorem. Step 1. The circuit converts all voltage sources to current by dividing the potential by internal resistance, where G represents the conductance of the circuit, where I is equal to E by R is equal to Eg. G is equal to 1 by R. The second step is calculate the circuit's total current using the following mathematical expression. I equation is equal to E1 by R1 plus E2 by R2 plus E3 by R3 plus so on En by Rn. I equation is equal to plus or minus E1 G1 plus or minus E2 G2 plus or minus E3 G3 plus and so on plus or minus En Gn. And this is the equation. So let's go to the step 3. The conductance of each current source can be calculated by mathematical expressions. First, 1 by R equation is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on until 1 by Rn. G equation is equal to G1 plus G2 plus G3 plus and so on Gn. Step 4. Based on Ohm's law, we can calculate the voltage at the open end of the circuit, which is parallel. Step 5. Calculate the current following through the load circuit RL. IL is equal to E equation by R E equation plus RL. Millman's theorem changes voltage sources into current sources and in circuits with voltage and current sources. Millman's theorem does not cover circuits with impedances among independent sources. Millman's theorem does not apply to circuits where dependent sources are completely independent sources. There is no application of this theorem when two independent sources exist in the circuit. So let's see the Millman's theorem example. Using Millman's theorem, find the circuit through and the voltage across the load resistor, which is RL, is shown in this figure. So there are three resistors here, R1, R2, R3. R1 is 2 ohms, R2 is 3 ohms, and R3 is 4 ohms, and RL is 5 ohms. So let's see the solution right now. So the step 1 is converting voltage sources to current source by dividing with their respective resistance. So I1 is equal to E1 by R1 is equal to minus 20 by 2 is equal to 10. I2 is equal to E2 by R2 is equal to 10 by 3, which is 3.334. I3 is equal to E3 by R3 is equal to 4 by 2, which is equal to 2. Step 2. Calculating the equivalent current. I equation is equal to minus 20 by 2 plus 10 by 3 plus 8 by 4 is equal to minus 56 by 12. Step 3 is calculating the equivalent resistance. 1 by R equation is equal to 1 by R1 plus 1 by R2 plus R1 by R3. R equation is equal to 12 by 13. The step 4 is calculating the equivalent potential. E equation is equal to I equation into R equation is equal to minus 56 by 13. And the fifth step is we have to calculate current through RL. IL is equal to E equation by R equation plus RL, which is equal to minus 0.727. From Ohm's law, VL is equal to minus 0.727 into 5, which is minus 3.635 volts. Thank you for